Okay, video overview for the second module. Quick overview, and we'll also look at 2.1 particular solutions. So, yeah, this is the merit/excellence level stuff. The previous module one, was the lead-in to sine and cos graphs, the A, B, C, and D components. And now we need to focus on these aspects here. The general solution is the one that sorts out if you get a merit or not. And modeling is the fun stuff for excellence level. And down the bottom here, formatives, which are old test standard papers to give you a practice, and also some test preparation hints. Let's just, this note in here, in theory, this says latest version here. You will have one that doesn't have the word latest version. You'll have your name up here. And basically, when this is pushed out, everyone gets the same copy. But inherently, feedback from you guys is a mistake here, or I'll go back through and add extra problems. So I'll update links, etc., etc. So, just keep wary that this one here is the live version, the latest version. That will have changes most likely made, but it'll be 95% similar. But definitely use this document, which has been pushed out to you, to show me tick boxes, writing in blue comments, and obviously scanning work I'm requiring you to do into the red boxes. Okay, that structure which we've developed on the first simultaneous equations and the first module for this trig thing. Okay, so let's get into it. This video will appear here, obviously. Okay, so start off by watching Mrs. O'Graham here. She does a good job, and she talks you how to use your graphing calculator to intersection to find particular solutions. Then jump across to page 11 here, and particular solutions. There's the word there, and obviously you can sort of see the logic here shown on in the diagram there. So page 11, let's click on here. Page 12 is so don't worry about the bottom example, although that is a different example. Don't use the TI Texas Instrument, but look at the two examples here, and here's some practice problems. Before you jump into practice problems, however, suggest that you definitely have a look at the Tahi Maths here. Okay, they're really good. You'll find these PowerPoints. Oops, let's just put some grammar in here. PowerPoints, really good. Let's just choose the second one here, for example. Okay, so the question is solve 2 cos x equals square root 2. And what this means is between 0 and 2 pi. So how many times, if you look at a 2 cos curve, that means amplitude 2, at what points does it equal square root 2? So graphically, between 0 and 2 pi. So we don't actually need to show this, or from this point onwards. And where is, there's the 2. You can sort of see the amplitude there. What else? There is the period. I think that'll show there. Hang on, click on this. Let's activate this. Okay, square root 2 is 1.41. If you didn't know that, that's about there somewhere. And there are the two solutions. Okay, so one solution is that one there. That solution there is going to be 0.7854 rad, or 45 degrees, and the other one, by symmetry, is 2 pi minus that value. And there's the other answer. Now, you could get this answer by using Desnos, obviously. Okay, let's look at this one here. This is a bit more interesting because it's tan. Tan is this asymptotic thing. Okay, repeating itself. There they go. Again, we don't need to show all the stuff over here because it only says between 0 and 2 pi. So when is it equal to 4? There's 4. That's one solution. That's one solution. That's one solution. That's another solution there. The period. Where's the period? Hello. The period is 2. Don't forget, period is That's interesting. 2 pi over b. I'm not liking that. Period is 2 pi over b. That should be at 2 pi in there. And ooh, interesting. I think it might be a mistake there in the Tahi maths. I'll get back to you on that one. Yep, so one solution is there, and by symmetry you can work these out. Okay, but easier to go to Tahi maths, not Tahi maths. Go to Desmos to work out the solutions for you. Okay, so bit of an issue there with I thought the b value, but very quickly let's just go to this one here, 3 tan 2x equals to 4, and go to our friend Desmos here. And the question was it this one? 3 tan 2x equals 4. So I'm going to go 3 tan bracket 2x, and I'm going to put under here y equals 4. By the way, you don't have to put y equals, it just assumes. And okay, and the solution set was between 0 and 2 pi. So let's put that in. And I'm just going to show it on here. I put 0 less than or equal to x less than or equal to 2 pi. It recognizes it as pi. And wow, there's our solution set there. Make it a bit larger, see what's going on. So it says between, that's one solution there. Okay, the other solution is that one there, the other solution is that one there, and the other solution is there. Now, this solution you'll be able to solve, as you can sort of see on the calculator. Okay, it comes out to be 0.463, 0.464, should we call it? And we can sort of see that logic. Yeah, divide that by, there we go, 0.4637. What am I saying it is? 0.463, yep, there's the 7. You can, 4 decimal places, that rounds up to 7. Okay, so yeah, cool. Go back to this bit here. Look at these other ones. This one here, just a heads up, I've got here fiddly. These examples involve trig identities. Now, trig identities, for example, if you had this in front of you, how do you start this? What you got to actually do here is you actually got to realize that's a squared function, and there's always these little tricks, okay, and then work backwards from there. This one here, you've got to use factorizing. You make a substitution, let z equal sine x. What have they done here? And yeah, I would have used different letter z, and so that's a quadratic. Hey, that's year 12 algebra. And from there, you should be able to factorize that. And you might realize there's some silly solutions. You can't actually solve that one. You'll never have sine x equal to -3. It'll only go as low as -1. So the wee little tricks in there. And basically, I've just put a note down here. This bit here is the next module, module 3, and that involves trig skills, and that's not needed for the assessment for this one. But if you're intending on getting merit or excellences in the monster externals, the integration and differentiation papers, then if you're a calc student, basically, if you're thinking engineering or hard sciences, hard maths at university next year, you definitely need to look at that third module. And at the moment, it is a work in progress, and it is being prepared at the moment, as you can sort of see here. That's the skeleton of it, and I'm just starting to put some funny memes in for you to understand what's going on there. Right, getting back to here, so if you could have a go at some selected solutions from 13 to 24. Selected, do a selection of problems. I just want to see 16 and 24 inserted in the red box there. So here we go, 13 to 24. I have given you, not quite sure why it's showing this, but in theory, that's a smart tag, and for some reason, the YouTube video does work. That's number 17, but it's not showing. If you don't want to watch a video, you just want to look at the PDF file. Pretty straightforward. Okay. You should be able to work your way through those. So 16 and 24 answers in there, and number 23 is getting advanced enough where you can actually, it's worth actually making a Desmos relationship expression for it. Okay, so answer the questions. Are you okay with finding particular solutions? Are you keen to use your graphing calculator or Desmos? Don't forget the first graph here for Mrs. O'Graham will really show you how to use graphing calculator. And lastly, some questions here. Yeah, don't write an essay, just a sentence or two would be fine in terms of answering the questions there. Cheers.